So I want to show how to use geometry software to draw a picture of a triangle accurately given some information. So my hope is maybe in a high school geometry class, you used geometry software or you did a compass and straight edge construction. And the geometry software tends to work like a compass and straight edge construction. So we have these straight edges. We're going to extend it a little bit by actually using a ruler measuring lengths, and then the compass is drawing circles. So we're going to draw some circles and some lengths and measure some angles and see if we can build this, and then we'll compare it to a calculation. So I'm going to use Geogebra, and I like Geogebra geometry version, but there's other versions. If you just search for Geogebra, if you're not familiar with it, Geogebra, and you get to their website here. They have a graphing calculator, which does the same stuff, slightly different interface, but has the same stuff in it. I'm using the geometry one here. So for the problem I have, I need to have 50-degree angle, a side opposite that of 26 units, and another side of 29. And if you randomly pick 3 values for a triangle, like side, 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 or angle, side, side, or angle, angle, side, you're not necessarily going to make a triangle. So could be this isn't a triangle. We'll find out. Geogebra has a little button down here for a keyboard, and that keyboard has useful things like calculator, some standard math stuff, and then the functions menu has your sine, sine inverse, and degree symbol, which we'll need the degree symbol shortly. Okay, so let's see. We need to, if you just click, you can move the screen around. And let's zoom out so we can see 29 and 26. Let's see how we doing. 29 and 26. Let's try this and see what happens. So first thing I need to do is set a baseline with a couple of points. So I'm going to go over to tools here, and we're going to need more tools in a moment, but we'll start off with a couple of points. So I'm going to want to point at the origin, and then I'm going to want to point elsewhere. Let's go out to, what was the other one? 29. I guess I need to zoom out again. So 29. And then the algebra panel shows the points that you made. And I want to double check the coordinates of that one. And it's not showing me. Let's do another zoom. Maybe it will, maybe zoom in again. All right, I just want to see that I'm on 29 there. There we go. So it'll snap to nice numbers. Another way you can check, oh, wrong way. And the wheel on your mouse will also scroll. All right, there we go. Is if you select the 3-dot button on any object, you can go to its settings, and you can ask it to show, instead of the name, you can do like the name and the value, which is kind of nice. And then I could switch to object A here and say, hey, give me the name and the value. So that's can be helpful. Let's get my picture out of the way. All right, we can close that. Okay, so we have 2 points here. We have a side of 29, at least we have 2 points for 29. Next thing I want to do is make that 50-degree angle. And then we'll talk about the side of 26. So I don't see the angle tool here, so I'm going to go more. And I want, this is measure an angle. I want to build an angle of a given size. And it says select the leg point and the vertex, then enter the side. All right, so this is my leg point. This is going to be my vertex. And it wants to do 45 counterclockwise. I want the degree symbol, so I'm just going to change that to 50. And I do want counterclockwise, right? Yeah, I want it to go up from there. Okay, and if it doesn't draw the angle in the right direction, just redo it. And you can also move stuff out of the way if they overlap. So I'm going to take the move tool, move that point. Oops, 50, you can stay there. Let's move A out of the way. And you might be in the way. Let's move you. All right, so somewhere here, we're going to find a length. And then remember the given information, angle A and side A have to be opposite. It's important in constructions of triangles. So here's angle A. So side A has to be over here. All right, so what do we got? So it's unlikely going to be the connection to these 2 points, by the way. So what is this point right here? Basically what GeoGebra did is it, from this point, drew a circle that it's not showing. And then on that circle, it marked a point that's 50 degrees away on that circle from the point I started with. So that's not necessarily the point I want. Let's see, let's make a ray through there so we can, oops, move along. All right. So from this point down here, I have to make a line that's 26 units long to get there. The easiest way to do that is from point B is to draw a circle and see where that circle of radius 26 hits up here. And that's where we want to be. So that's the whole kind of compass thing. So we want circle with center and radius. So this one right here, you plot a central point and then a point on the circle. This one here, you plot a center and a radius, which is what I want. So here's my center. And then my radius is going to be 26, the other side. Again, that side 26 had to be opposite. And look at that circle hits twice. There's two possible triangles that fit the given information. Let's double check. Given information was angle of 50 degrees and opposite that a side length 26 and another side of 29. And it doesn't matter whether we put the side 29 down here on the bottom side or up here on that diagonal. We can go either way. I just chose to put it down there today. Usually I put it up top. All right, so what do I do next? I need to find these intersection points here and here, and somewhere there's an intersect tool for that. So let's look for point stuff, more apparently. And there we go, intersect point. So it works in two different ways. You can find the intersection by clicking on it or click the two objects. So I'm gonna click the two objects because I have two intersection points. So I wanna see where this thing intersects that thing. So it gave me points C and D. So I got two different triangles here. One triangle is A, C, B here, and the other triangle is A, D, B. So I'm going to draw a couple more lines. Let's use the segment tool. So again, here's one triangle down there. That's one possibility. Let's undo that. Other possibility is it's this triangle right here. All right, so let's look back to see which one they want. Use the law of sines to find one obtuse angle if angle A is 50 degrees. Okay, so what did we get? So here I have 1, 2, 3 acute angles. And if I go back, undo that, and go to the other triangle, all right, here I get an obtuse angle for angle C here. It's going to be an obtuse angle. And now another thing to keep in mind, GeoGebra picks points in the order you plot them. So A, B, C, D, and so on. That is not necessarily going to match the A, B, C, D in your problem. You could rename things if you like. So maybe I'll do that. Let's see, angle A and point A, let's line those up. And then if side B is 29, then this should be point B right here. So I'm going to take that and rename it so it's not so confusing. So I just click the move tool, click on the object, and then the 3-dot button lets me get into its settings and I can rename it. And if I call this B, it's going to rename the other B for me, which is kind of cute. Enter. So that's now B, and they're calling that B1. So let's rename that. We'll call that C. So click on that. 3 dots, rename. You don't have to rename them, but if I don't rename them, I sometimes get confused about what's what between the problem and my picture. All right, so this is the triangle I want because they said I wanted an obtuse angle right there. Now I've built the triangle. This is it, right? So I know I have a length of side of 26 right here, and I'm going to double check that in a second because it's on a circle of radius 26, right? We built that circle of radius 26. That's a radius right there. So I'm talking about this line right here. And then I know I built this line at the bottom to be 29. So we can figure out what this angle is, that angle is, and GeoGebra will measure those, compare that to the law of sines. So next thing I want to do is draw the polygon on top of that. So A, B, C, back to A to finish the polygon. So that's, I'm just kind of just highlighting it there just for fun. And then I have some tools here for measuring angles and lengths. So let's measure some length. So I just want to confirm. So it's click on 2 points, a segment, polygon, or a circle. So what happens if I click there? It's probably going to pick the whole thing. Nope. Okay, so there's my 26. Here, I'm going to click 2 points because there's lots of things going on this line. So A to B, and it picked AG. What does AG mean? Interesting. I'm thinking that's got to be this side right here. All right, so it picked for me. That's interesting. Usually it gives me a choice. Let's move that over here. And then to get, say, angle B, that obtuse angle, we need the measure an angle tool and select 3 points or 2 lines. So here I find 3 points is the better way to go to get the angle you want. And the vertex point has to be in the middle. And if the order you connect them will tell you whether you get the outside angle or maybe the inside angle. So let's try A, B, C. There we go. If I went the other way, it would have given me the outside. So it says that angle is 121.3. All right, so again, and I could use the same thing here. So now I know everything about this triangle approximately, but not exactly. The only way to do it exactly is to do something like use the law of sines. So I'm just going to go to the algebra panel and tell you what the answer to the law of sines is. And again, everything on the screen here is in the algebra panel somewhere. And I can choose to show and hide things by just clicking on them, and they'll start disappearing. So I'm going to scroll down to a new line. So with the law of sines, with this information, if I want to find angle B, I would do the sine of angle B over side B equals the sine of angle A over side A, and solve for angle B. The result of that, I'm sure you can write that down on your own, would be that my angle is going to equal the arc sine, or the sine inverse. Actually, let's use their sine inverse function. The sine inverse of 29 times the sine of 50. And they put the degrees in there, but sometimes I put it in just to double check. 50 degrees. And then outside of that sine, but inside the sine inverse, there's going to be a divide by 26. And that is going to be, remember, the arc sine only gives us acute angles. So that's the acute angle. If I had drawn the triangle with D, to get the obtuse angle, I just do 180 minus that. So I'm going to sneak in front and do 180 degrees, don't forget degrees, minus that. And there's the 121.3, which should match the angle I have here. So GeoGebra allows you to construct triangles to kind of double check what the trigonometric functions give you. Hope you found that useful. Take care, do good math.